Okay, we're now about to look at the fat file system. Here is really where you should read this page on Wikipedia, and you can see it's fascinating stuff, and it goes on and on and on. And fat is regarded as one of the simpler file systems. In fact, it's not that difficult really, it's just there are an awful lot of details. I'm going to first of all look at one thing, the directory entry. But first I want to, I'll leave that page there and just remind you. Actually, it just was one thing. I should maybe have to go back to the beginning again. And yeah, so yeah, the directory entry. Okay, so they're only 32 bytes. So 32 bytes will be a directory entry. And you're told where they are, and the various parts. So that's all them. So this is only 32 bytes, right? So that's easy enough. You're just given the addresses and explanations of them. It's usually much easier to see these in action, which is what I propose to do now. Let's create a new terminal, and let's also start a virtual box. I've already set up my, oh yeah, this is off. First, one thing you should do is to go to storage. I'm going to do this with a floppy controller. Now there's a floppy on that at the moment. It usually comes without it, but you can just add a, oops, I wanted to add a, what is that? That adds a new storage controller, and I want to add a floppy controller. Okay, so now I've got my floppy controller, and which means I think I can add a. Can I add a? Yeah, I can choose a disk. Well, first of all, I want to show you how I create a disk. So I have a little setup here. Oh yeah. Now there's a floppy disk there already. I'll just cheat and I'll go back to the way I already created. So if I just do a search for floppy dot image, oh yeah, oh wow, there's a lot of those. Oops, I wanted to get the last one. Yeah, okay. So this is a program. This line, I guess it could look complicated, but right, it's just a way of adding the text pattern empty 000 to a file called floppy. So DCFLDD, it's a special program which is designed to easily create certain kinds of files. So there's a block size of 512 and there's a count of 2880. So in fact, and the floppy disk has this size, it's got 2880 sectors of this. Now I didn't happen to know that until I just looked at that there, but I'll just show you what happens when you run that. It writes these blocks out to this file, and you can just maybe use less to view it. Okay, and you can see it just has this expression over and over again, empty 00. And there's a reason for that. We can go down to the end of the file. It takes a bit of time. It's over a megabyte. Okay, it's a megabyte and a half, I think. Okay, so ls minus l, and you can see that's the floppy image, because back in the day when people used floppies, that's how big they were. Now you might wonder why I'm showing you this. It's a handy way of showing you the fat file system, which is still used in a lot of things, even though it's hard to get storage that low, which is just 1.5 megabytes. Okay, so that's that. So let's let's add that to. Okay, so I'm going to choose a disk, and it's this particular floppy image in there. Okay, so that's the disk. So that's now been added to Donald. Now, one thing you'd also want to do is to make sure that your floppy is not set to boot. It had been for me, and I couldn't understand why the system wasn't working. I had an empty floppy in the thing. I was trying to boot from that, and so that's one thing you want to be careful of. Okay, so now I just want to start Donald off. So it's booting up. Okay, and now I want to start up my Explorer, Windows Explorer, so I can explore my windows. Now there should be a floppy there. And let's see, maybe I have to wait. It's usually, There it is. Oh yeah, maybe it doesn't appear there because it's not formatted. It only contains nonsense at the moment. If you want to do something on the disk, you have to format it. But first, before that happens, I want to do my little watch window. So if I go over here, okay, if I do XSD, say floppy, you'll just see loads of these empty. Okay, so that's fine, except it's not really, it's a bit boring. What I'd like to do is if it only showed me changes. Now there's a program called Unique, and if two lines are the same, it won't show the second line. Okay, now all these lines are actually different, so it didn't make any difference because they have the address. But you can tell Unique to skip the first field by doing -F1. And now, if you don't count this address, every single line is exactly the same. So Unique just shows one line. Now, the problem with that is you don't know how many lines there were, but you can tell Unique to count if you add a -C parameter. Okay, so Unique -C -F1, and it counts them, and it tells you here there are 92,000 lines of this. So in just one line, you are being told everything that is in this floppy image file. Okay, so that's fine. I can do this, and I can just see exactly what's in it. And if it changes a bit, it'll show me a little bit. So it's a little bit hard to read this, but you get a very compact representation of the disk contents. So now I'm going to stick that into a file. Actually, I've done it down here. Now I'm also going to change this. There's two other parameters to XXD that I want to stick in, and one is 0, which means I0. So I stick in a 0 there, and let's stick in. I think that's. Let's get rid of the length. Okay, so it's going to skip 0. So this is effectively nothing. I'll use it in a minute. Okay, so now I'll skip that and write it. So now I have this file, and now I can do watch -D, just shows the differences, -N1, this is every second, and I want to run that file here, which is just going to display that floppy. Okay, so it's running it, and I can see now it's continually displaying this. There's nothing there. But watch what happens when I format it. So I'm going to format this floppy, and you'll see the changes over here. Let's call this the watch window. So I'm going to format that, and okay, choose all the defaults. This is all standard, and it warns me you're going to lose all the data, and that's complete. And you can see, ooh, it seems to have all changed, except really most of the changes occur in the first block, and that's why I want to go back in here. I want to skip the first block because we're not going to see those. Now those, as far as I know, those don't change after the first 512 bytes. Okay, so I'm going to 512. Now this will effectively tell the watch program to skip the first 5,000 bytes. So now I'm just saying the first 512 bytes you can't see anymore. If you go to the Wikipedia article, it basically says that the first 512 bytes are the bias parameter block, and the bias parameter block. So, that's actually. Oh yeah, I think the first 25 bytes do this, and it goes on and on. But usually, I don't think it changes once it's been set up. So there's lots and lots of stuff there. And it's not terribly interesting for most purposes. In fact, what happens is the file allocation table has a fat, which basically, that's quite a bit of data. There's this one line here, and then at the moment it's all empty. So there's 287 entries there, and the fat is repeated. So you get, there's actually 287 entries part of the fat, and the other zeros are the directories. And then you get the data area. So this is where all the data would go, and that has not been modified at all by the format. And finally, I'm not sure what these 32 lines at the end are. However, that's so that's our disk after it's been formatted. It has the first sector, that's just less than 200 hex bytes. Then it has the fats, 2 fats, and then a directory area, and then a data area, which is this. Okay, so let's see what happens when we create a file. Okay, so I've just formatted it. Okay, and I'm gonna, I want to close that. And let's open this file. Okay, and let's create a file. A new text file. Okay, let's create a new text document. Ooh, and look what happens. Now, so there are your 2 fats, just to remind you. There's the other fat. And this is your directory area. Okay, now you're probably wondering what this is. It does look a little bit strange. And what happens is that the directory entry, there are 3 directory entries here. That's 1. Each directory entry is 2 lines, or 32 bytes. There's 16 bytes per line. So there's another directory entry, and there's another directory entry. Now this directory entry is the most important. And when floppies came out first, they could only handle names of at most 11 characters. And Windows eventually adapted it to handle long file names, and those long file names were put into some dummy directory entries. So that's these 2 here. These are dummy directory entries. So this is the directory entry for this. It has a name. It has 2 times corresponding to these things here, and it also has the cluster that says where the date of the file is. There's no data in this file, it's just a name at the moment, and a length. Okay, that's the length of the file. Okay, and it's 0 at the moment. Okay, and these are just 2 dummy entries to contain the name. You can see MENT at the end, MENT, it's 16-bit Unicode, and new text document, the rest of it is there. Okay, so that's it. I mean, that's not terribly important, you don't have to know that much about it, but what is very interesting is, let's say I change the name to John, for example. Let's change it to test. Okay, I click enter, and now you can see that this entry has changed, but these ones have not. And this is very useful. This is very useful forensic information. It's not terribly useful, I suppose, in a way, but it does show us that somebody right-clicked on a document, and it gives us the time that happened, and then when it was renamed, a brand new directory entry was assigned. Okay, so it is interesting to see exactly what goes on, which is what we can do here by watching the actual hex values as they are written to the drive. Okay, so now I want to say delete that file. If I right click on it and delete it, just to show you what happens. Oops, I didn't mean to do that. I meant to delete the file, not delete the name. Okay, so it's asking me if I want to permanently delete this file, so I click yes. And if you look and see what happens, actually only 1 byte changed there. And that is the first character of the name. It went to an E5. Okay, Now you can see what a T is. A T is 5, 4. So this is the ASCII value for T. It became E5. Now you can use an editor to modify that, and I downloaded an editor for this purpose, which was called WX something. And if you open this file, and so this is the entire file, and I could run through that, but it's simpler to search. So let's search for, now if you are doing search, it starts off by defaulting to hex, but I want to search for, let's say, oh yeah, EST. Yeah, no, I think there might be a problem with that. No, actually, yeah, this program is, a lot of these programs are very sweet, but a lot of them also aren't very good. Well, they're written for programmers, which is part of a problem, because they know the programmers will be able to handle it, and so they don't make them terribly user-friendly. Okay, so let's move down. Okay, so there's a load of zeros there. That's actually, what address are we looking for? We're looking for 2680. Okay, oh, we're way past that. How did we get so far past that? 26. Oh, these are decimal. Why? How do I change that to hex? That's nuts. Who uses decimal in a hex editor? Okay, so, oh darn, okay, so this is going to be hard work. Okay, so let's just keep moving. Oh yeah, here they are. Okay, so there's my test file. So if I click on that, okay, I'm over here at E5. I could change that if I change it to a 4. Okay, now you can see it's actually E. So 4, 5, 4, 5 wouldn't make that EEST, which is a strange name, but sure, it'll do. So let's save that. Oh, hang on, I want to save, not save as, save. Okay, so if I go back to here, you can see that the floppy drive has changed. However, Windows is fairly clever, and it knows that nobody ejected that. If I press F5 on this, it doesn't show me this file, even though as far as it's, if you look at the disk, that file should still be there because you've undone the delete operation. So what we could do is remove the disk from the drive and then refresh it. It'll ask you to insert the disk. F5, by the way, is to insert. So we go back to this and we press F5 and you see the file has come back along with its times and its size of 0 kilobytes. Okay, so in other words, it's quite easy with a hex editor to bring files back. Okay, let's create another file. Let's create a file and let's call this file, let's just call it John. Okay, and now this has created another file, John. Now there's a problem here. I'm not really using all this information up to about here. Okay, so what I'd like to do is just not, all these are wasting space really. Sort of wasting space. Actually, maybe I could just move this down. Yeah, that's what I'll do. I'll move that down so I can display more space. Okay, now what I want to do is to put something in John. Let's say I'll put in hello there, how's it going? Save that, and we should be able to see this over here. And there's the data. It's ended up in john.txt. Now you should notice a couple of things that will happen here. This is the length, and this is the first cluster. And if you look at the fat corresponds to clusters. It's a bit weird, but anyway, this is the address of the first cluster, and it's basically just saying, and it's repeated here by the way, there's two fats in an exact copy of each other. And usually this points to the next cluster. However, there's only one cluster in this file, so it just it's got the FFFF to hide that. Okay, right, now I just want to quickly show you. Let's start up a... Now, just to have a look at this value here, 1A000, that's actually the length. Okay, and I'll just show you just translate that to in order to decode this. Well, that's not really decoding it, but it's basically little endian. So these two zeros here are the most significant. So if I'm translating that to a number, it's 00, 00, 00, 00, and then 1A. Okay, and that's actually hex. So if I want to convert that to decimal, in Python you can just stick hex in front of that, and you get, oh sorry, what happened there? No, that's wrong, it's already hex. I don't want to convert it to hex, I want to convert it to decimal, and you do that this way. Well, anyway, A is 1 more than 9, so it's 10, that's 16, so it's going to be 26, but you might as well let Python do the work. Okay, so let's go in here and let's have a quick check, and we right click on this and get the properties, and you can see it is indeed 26 bytes. Okay, you can see also the size on the disk is 512 bytes. That's because it requires the smallest amount of space you can take is a cluster, and it's always going to be a whole number of clusters. So in fact you can see, so there's the text, how's it going, and immediately after that are loads and loads of zeros. Okay, see all those zeros. In fact, there's 30 lines of them there, as well as these. So that's padding out the rest of the cluster. Okay, and this whole thing there will be one cluster. So that's obviously remember each row is 16 bytes, so that's 16, that's another 16, and 30 times 16. So 32 times 16 is 512, which is a cluster. So 512 is a fairly magic size. Anyway, if your length is less than 512 bytes, it's still going to require 512 bytes on the disk, because that's the minimum amount of space it can take on a fat file system. Okay, so that's that. Right, let's change John and make it a bit different. Now, one thing, I'd like to make John way, way bigger. The only problem is I won't be able to show you all this unless I make it all the same. So one way of doing that is, let's just type John, and let's copy that and just keep pasting it. Okay, and I can do it again. Oops, what happened there? Copy that and keep pasting, and the file gets way bigger. Okay, I could do the same thing. Okay, so now my file is a little bit bigger, and you can see, oops, what went wrong? Oh, I started with N, John. Oh, was that right? Why is that not working? Oh, that's because I'm looking at the fat. And the fat keeps showing these so the directory entry points to the first cluster, which is a 3, and then you get a 4. Now they're written in a funny way: 5, 6, 7, 8, 9, etc. A, B, C. So it's just indicating that each one is going on. So the fat is taking up a lot of space here, and then there's a whole load of zeros, and the fat is repeated there. So that's the reason I can't see it. So I'm going to go back here, I'm going to edit this, and I'm going to move on a little bit. Let's say I move to, I can't see now, but let's just choose, skip. Okay, so I want dollar bracket, and I'll make it plus 32, let's say star 32. I'm really only guessing here. Oops, I don't want to do that. I want to escape and quit. Okay, now let's see if that's any better. Oh, I'm still in the middle of fat, whatever happened. Oh yeah, here's the directory. Actually, I want to stop it around about there, so let's choose that. Okay, so I'll go here and so I want to start this at, forget all that. And you can say dollar and just OX and so this is going to start viewing at that point, and so I should be able to see it a little bit better. Okay, so there's a new text document that's deleted. You see the E5 there, the first line of the directory area, directory entry. There's the next one is john.text, and you see there's a length. Okay, so let's have a quick look for the length, and then you see John, and you see 479 of those, followed by another 2. Okay, so let's go to let's go back to Python, and let's just calculate this length. So it's OX 00, okay, 01, 36, oops, 36, D8. Okay, so that's the length. So we're getting that length there. So let's go to our thing, right click on that, click on properties, and it's saying 79576 bytes. You see exactly. Now look, we can also check it here. There's John, so 4 Johns, 4 4s, 16. So we can also see we've got this number. Okay, we multiply that by 16 to get the number of bytes here, plus 8. There's an 8 bytes here. So that should be the number of characters. And you can see it's the same. Okay, when we look at the data, when we look at the directory entry, when we look at Windows telling us, they all match. So it's pretty convincing. Okay, so that's how you create that file. Now that you have the file, I want to show you something a little bit crazy that you can do. You can see here that that's john.text, and we have, where's EE text gone? Maybe that's further up. Okay, so maybe I have to go back a bit. Let's go back here and move up a few rows, maybe go to 0. And okay, so it's going to show me, oh yeah, there's E. Okay, I didn't realize I was up above this. Oh, because there's another new text document, that's the reason. Okay, so let's say this file is length 0. You kind of feel a bit sorry for this file, considering that this file is 78k. So let's see if we can do anything about that. How about we edit this and give it a length? Now we also have to point to some data, but there happens to be some data already at this location, because this file has its data at 0200. Now this would normally be a problem for fat, and if you ran check disk it would complain, but we won't run check disk. Okay, so let's go over here. So I want to make that 0200. That means it has a cluster, so it's 0200. You can see, oh sorry, it's John EST. Oh, I thought I just made, oh, I haven't saved it yet. Okay, so now I want D8360100. Let's make it the same size. So I want D836 and 01. Okay, and that's so I've changed the directory entry for this file. I've said that it has some data pointed to where it is, and I've given it a length. Okay, now I have to save. Oh, I must have saved it, did I? How come? This is reading the same file. Okay, yeah, so I don't have to. It looks like. Oh, sorry, I haven't saved it yet. They're all still zeros up here. So I do have to save it, which makes sense. I was a bit worried there. Okay, so now it's changed, and you can see it has exactly the same entries as John. So now, unfortunately, if I, because it still reads as 0, if I refresh the page, Windows knows that nobody could have been writing to it because it's in the Windows machine and it didn't do any writing. So I have to eject it. And I'll then click refresh and it asks me to insert the disk. So let's insert the disk. And now when I press refresh, you can see, look, ESST and John are both the same size. If I right click on the properties of EEST, oops, I clicked on the wrong thing. Properties. Yeah, you can see it's the same size. Okay, so if I double click it, you can see it's the same contents. Okay, so I kind of cheated there and I made John point to the same one. I could make it much shorter. Let's make that a 0. I mean, I know that's only a 1 that I've changed, but it's the most significant one, and it'll make the file more than half as small again. Okay, so I save that. Let's go here. Again, if I F5, nothing happens, but if I eject it, click F5 and insert it and click F5 again, you can see it's only 14K. Now still the same contents, it's just looking and it just sees it's going to just print that much. Okay, so the file system really depends completely on the bytes that are here. There's nothing else, there's nothing mysterious about it. And there are lots of anomalies. Again, as I said, if you ran check disk on this, they'd say, hey, hang on, this file and this file are both claiming the same clusters, and that's an error. So it would give you an error. Okay, so that's that. Now I want to do another thing here. This is still pointing to the same document. So let's say I start up the editor again, and let's say I just change this text. Let's make sure we can see the watch window. Okay. Hey, I didn't mean that to happen. Okay, so I'm just going to okay, so let's move that over there. Hopefully that'll do. Yeah. Okay. So now I'm just going to say hi again. Stop. And now when I save that, you see something happening. Okay, so you can see EEST, which is this file. Its length is only 9 characters, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So its length is 9 characters, but it's still at the same 0, 0. Now what happens, because when Windows is writing to a disk, it has to write in sizes of 512 chunks. So it pads out the rest of it with zeros. And so here is your 512 bytes. Remember, 16 plus 31 times 16 is the same as 32 times 16, which is 512. Okay, so that's 512 bytes. So these zeros were because it had to pad it out. It's called RAM slang because in the old days it used to actually contain RAM before people said, hey, you shouldn't be writing our RAM contents out to disk. So it's always zeroed now, and it's and you can see that. And then the remainder of the file is still there in this following clusters, and you can see there's a lot of data there. Okay, so that's that. Now there's So you've got a bit of an idea of the file system. I want to now show you what happens if oh yeah, so actually let's delete this file. Close. Sorry, no, I don't want to do that. I'll just try deleting this file and seeing what happens. So when I delete that, so I'm asked, do I want to permanently delete it? So I delete it. Now what's interesting here is this is going to change the fat. Okay, it's going to mark. So this occupies this cluster, so it's going to mark that as unoccupied. And this is going to cause a problem for this file because its cluster is now going to be marked unoccupied. So I'm not 100% certain it should actually realize there's a problem for a few reasons, but let's see if it does. No, it doesn't. Okay, so it's just marked this is deleted. Okay, so the E5 appears there. Okay, what I'd like to do now is look at the fat, but let's just see if I can access John. Okay, because John still thinks its data is there. Yeah, so nothing's happened when I try to open that. And it says a file or directory is corrupted and unreadable. Okay, good, as we predicted. Excellent. So so you can see, you can mess around with the file system and have great fun. Okay, I just want to see what happens now when I format this. I'm going to go back and set that up to maybe actually what I'll do is I'll change that to 32 times 16, which, as you should know, is 512, and so you'll see the fats there. Okay, so the fats have been set to 0, which is why John's file was unreadable, even though it apparently is a valid file with a valid length, and its data, most of its data is still there, but because it went off, the fat contains the next address. So I know that my first cluster, John will know that his first cluster is in 02, so it goes to the fat to find the address of the next one, but there's nothing there, which is why you get an error. Okie doke, that was that. I just want to format this now, see what happens. We'll format that disk, and we'll actually might as well give it a label as well. Okay, so we're going to start, and it'll say it's going to erase all the data. Oh, it's saying it's in use. Ooh, okay, let's hang on, and maybe, oh yeah. Okay, so the format is complete. Now there's the label. Okay, the label takes up a directory entry, and there's a directory, and there's all the data. The data is completely unphased. We need to, okay, actually I wonder, can I kill that? Okay, now I want to format it again, except get rid of this option to show you what happens when you get rid of that. So I'm going to start, I'm going to change the label to U, and click start. Okay, so it warns me it's going to erase all the data, and this time it does actually erase the data, but it does it fairly slowly. Relatively speaking, it finally erases it all there. Okay, so that's that. So that's floppies. That's how they work. That's what it's like when you can see it as it's in action. There's a lot more really to the fat file system, but hopefully you've got the basics of what happens with that.